This is assignment 3, but we are talking now about question number 6. Okay, my carrot is a little wet, so I'm getting some problems here, but it should be okay. Number 6, there we go. Now number 6 is related to number 2 because it's about the balloon. So first of all, we have to go back and just have a quick look at how number 2 worked out. It was a balloon, and you had to figure out what the rising force of the balloon was. So let's draw a balloon. There we go. It has a force pushing up, which is the hot air inside the balloon. I'm going to call that FB, force of balloon. And then, of course, it has gravity pulling down. So it's a simple picture. And we had to do a quick F net here. This would be an F net Y because it's up and down. And F net Y. And we have FB and FG. Those are the two forces that are involved. MA is the net force. That doesn't change. The force of the balloon is sort of what we're after. And then FG is going to turn into mg, right? And then we're going to put in some directions here. The mass of the balloon was 250. The A was told to us as 0.3, and the FB and the mg was now down, right? Negative force. Gravity's pointing down, 250 and 9.8. So we got to crunch a few numbers here to figure this out, but you can see from the equation that FB is going to pop out, the force of the balloon, right? So let's do the math. If you take 0.3 times 250, that should be about 75. And then 250 times 9.8 should be about, let's see here, 2450. So you put those together on the other side, you end up adding them, and you get 2525 as the force of the balloon. Right? So let's say we figured that out. I'm hoping that's, I don't have the sheet in front of me. I'm hoping that's the right answer for that one. Hang on a second. You know what I can do is just quickly look it up here just to make sure we're doing the right thing. So that was the assignment number 3. Give me a second. Forces assignment. Okay. Question number 2. Yeah, so I think that looks about right. 25, 25. And you should put newtons in there. My mistake for going too fast. You should put newtons at the end for your unit. Okay, so that was number 2, and that told us the force of the balloon, which is going to be useful in number 6. Okay, so now number 6 is slightly different. We have a balloon, which means we still have the force of the balloon going up and the gravity going down. But what's new here is the question says that the balloon's getting too high, so you grab a little rope that's hanging from it and you pull down, which means we have to add a force. Now, the thing to remember, we'll call this force pull. The pulling force. You have to remember that the other forces don't disappear. While you're pulling on the balloon, there's still gravity. It's not like gravity gets erased. So now we just have a third force involved. And if we do our F net, what happens now is we have 3 forces. The force of the balloon, the force of gravity, but we also have then the pulling force of U on the rope. Now it gives us some information in number 6. We want to pull this back down at a constant speed. That's interesting because that means that this side is going to turn into 0, right? The MA, there's no acceleration. We have the force of the balloon from the last question we can throw in there. We can do the gravity again, mg, but we also figured that out in the last question. So we actually have that number as well. And then we're going to add. Now when you add the pulling force, remember it's downward force, and you're going to have the force of pulling. But here's an interesting thing. Because we don't know the force of pulling, even though we know it's down, it's better to leave it as a positive number. Because what that means is that we're going to let the math decide what sign the pulling force should be. A rule of thumb is never force a variable to be a positive or negative. That's why I always say only put in the negative sign when you're adding numbers. If we're not adding a number for FP, we'll leave it as plus and we'll let it work itself out. Okay? So when you do that, well, let's just do a couple more steps for you. Remember, the force of the balloon was 25, 25. So that goes there. And it's up. The force of gravity, we also figured that out over here. It was right here, which is this number, 2450. That's the force of gravity on the balloon, and it's down. So minus 2450. And then we have the force of pulling, which I'm leaving as a plus because I don't have a number for it. Because you can see what's going to happen. When you subtract these two numbers, the 2525 and the 2450, you're going to get a relatively small number of 75. But it's going to be okay, let's write it in. 75, like this, equals 0. When you move it to the other side, it's going to turn negative. Which makes sense, because we wanted a negative answer because of the downward force that we were pulling. So you see, what happens with variables is the math is smart enough to figure out which way they're going from the information that you put in. So that's why you don't put a minus here until you're ready to put in a number. It's okay to add a minus sign with numbers, but don't add it for a letter for a variable. There are situations where you can do that, but it creates problems. So I tell beginning students to never do it, and then later we'll learn when it's okay.